Objective 111. Everybody take a deep breath, make a wish. We got 111. I'm sure. You ever do that when you see a clock?
It's supposed to be 11.
Yeah.
11?
Yeah.
Anytime. 222, 333. You gotta make, you see, you can get lots of wishes in.
444.
1111 is just like, you said your best wish for 1111, but we are not doing 1,111 objectives this
You
year.
can't just make out something like that.
Oh no. Every time that you get triple digits, come on now.
It's
Look it up. Google it. Short digits, wishes.
Or at directly midnight on a 24-hour
I've
clock.
never done
000.
If mine doesn't go true.
Oh, 000? Okay. I
It
gotcha.
works.
Gotcha.
Yeah,
I
my
might
wishes
try.
came true.
Just came true. The wish that we would not start the objective, we would just talk about wishes. That was Keaton's wish. Okay, here we go. Let's just go through the front page. No work to do, just lots of blanks to fill out. Things that you know already about systems. So we'll see how much that you can answer here. And I'll have to fill in if you don't know. All right, here we go. Recall the three possibilities that may occur when graphing a system with two equations. First off, the two lines cross somewhere. I'll do that there. Two lines cross somewhere. That means you're going to have exactly how many solutions? One solution. Let's see. Two lines cross over. Exactly one. This happens every time that you have, any guess? Didn't mention it, but it kind of went in passing.
Parallel lines.
crossing lines.
Crossing lines. There's different slopes is what I'm going for.
That was close.
Oh, I forgot.
Anytime that you have different slopes.
Oh, never mind.
I didn't give you much of a blank for that. But... All right, so if you have two equations, they have different slopes, they sure as heck are going to cross somewhere. All right, the two lines are parallel. Here's where Keaton's at. The two lines are parallel, and they do not cross. This means that you will have how many solutions?
Infinity.
None.
No solutions.
Yep.
They don't cross, they're parallel, no solution. This happens every time you have the exact same what?
Slope.
There you go, exact same slope. And you guess what the other blank is? Different intercepts. You have the same slope but different y-intercepts. Put
Same,
y-ins. So if you had y equals 3x plus 6, and you had y equals 3x minus 5, those lines are parallel. They won't cross. So you can keep that in mind. Two lines are exactly the exact same line. This means that you're going to have how many solutions? Two blanks.
Infinitely.
Infinitely many.
Yeah.
Infinitely many. Somebody next hour, they always say indefinitely. Indefinitely. I'm like, do you mean infinitely? No.
You don't say that word.
I mean indefinitely. Infinitely many solutions. Should make sense. The solutions where they cross, if they're on top of each other, they're crossing an infinite amount of spots. Infinitely many. This happens when you have the exact same
Slope.
and the exact same y-intercept. There you go. How many solutions does this system have? Okay, so with just knowing that little knowledge, remember, if you have different slopes at all, one solution. Same slopes, different y-intercepts, no solutions. Same slopes, same y-intercepts, infinitely many. All right, this one is in mx plus b. That's fantastic, already there. Look at this one. Let's put it in mx plus b so we can check on the status of its slope. What do we got to do?
Divide -2.
Negative 2, negative 2, negative 2. Let's see what happens. You divide them all by negative 2, and you get y equals what?
Positive 13x plus 3.
Plus 3. Okay. We have the same what's here,
X.
which is the same slope, but we have different. So that means how many solutions we're going to have?
No.
None, right? That means same slopes means parallel, different y-intercepts. So we have no solutions. We don't even have to graph it. We don't have to do substitution. We don't have to do anything. That's it. Oh, who's got it today? Who's got it? Who's got it? Keaton?
Next one. Next one.
He's got the next one. Taylor?
Hey, don't let
Brian?
me do it. I just pitched
Piper
pitched
did it.
yesterday.
There we go.
Can't straighten my
Oh,
arm.
3, 2, 1. Oof. Oof.
Yeah, Pat.
Too much pressure.
Yeah, Pat.
All good. All good. All right, here we go. Backside. 3 examples. So we're done after these 3. Here's the deal with objective 111. When you come across 111, it is not 4 multiple choice answers. There are 3. It is how many solutions will you have? 1, none, or infinitely many. So it's A, B, C. 1, none, infinitely many. We're not even trying to find the answer if there is one. We just want to know if there is one. Call it 1. How many solutions? Here's how we want to do this one. Let's just put them both in a y equals mx plus b. And think, if they have different slopes, what are you going to say? Different slopes always have how many solutions? 1. If they have the same slope, then we're either going to go same slope, same intercept, or same slope, different intercepts. So it'll be either no or many. All right, put them into y equals mx plus b. This one's there already. And this is what happens on this objective a lot. One of them's there, one of them's not, so get that one there. So divide just like before. Divide all by -2. I'm going to end up writing it over here. This is going to be y equals what?
-3x.
Already know something's happening. And then this is what?
Plus 8.
Plus 8. Yeah, would you say these are parallel lines or the same line?
Same.
Exact same line. So when they're exact same line, how many solutions?
Infinitely.
Yeah. So if we want to shorten it up, we can put just
Indefinitely.
inf many.
Or you can just put the infinity sign.
Yeah, the sideways looking
Yeah.
8 thing. Infinitely many solutions. Infinitely many solutions. That's the exact same line. They're on top of each other. Infinitely many solutions. Okay, this is example 2.1. This is the exact same problem. Now we're going to do it a different way. We've been doing substitution a whole lot. So say we're doing substitution. This time we put them in y equals mx plus b and we're able to see it.
How many solotians?
Yes.
Solutions?
Solution. We're working on our pronunciation here, freshman year.
That's a go. Solutions.
Oh, solutions? You're going with my handwriting. Hey, I can zoom in on that. There's a little, barely. Enough though.
Ooh.
Enough to make a ooh sound in there.
Solution.
Okay,
From far away.
so exact same problem. You know the answer is going to be infinitely many. Not a mystery. I want to do it with substitution. What am I going to circle?
-3x plus 8.
Okay, circling that. And I'm going to sub it in for what letter in the other equation?
Why?
Okay, so rewrite the top equation, putting this in, and then you're going to find out what infinitely many looks like if you're trying substitution method. -2 times 3x plus 8 equals 6x minus 16.
Whoa,
And you try to work it out.
Jones, why is there no negative?
Where?
In the 3.
Oh, that's supposed to be negative?
Mm-hmm.
Yeah, there it is. Good call. It just kind of got lost in my Sharpie marking.
Got you.
Yep, so good call. That saves us right there. Okay, work this out. Distribute. This is now 6x minus 16 equals 6x minus 16. I would say get your x's together first. So minus 6x on each side, and look at what happens when you do that.
It goes away.
It goes away. X dies. Anytime x dies, it's no or many. Stop right there. X dies. Look at what's on the left and the right of your equation. It's 16 and 16, right?
It dies.
So when you got 16 and 16, what are we going to say? Infinitely many or no solution? Infinitely many. Infinitely. Before we used to say that was all real numbers when we were doing like number line stuff. Now we're going to say infinitely many. If you would work that out and got like 0 equals 16, that would be no solution. Anytime x dies like that, though, it's one of the two. It's no or many. Now this is class vote on this one. This is a different problem. Do we want to do it like we did the first one? Let's make them both y equals mx plus b and just check on their slopes and y-intercepts. Or do we want to do substitution? So who says, let's just do y equals mx plus b on both of them? Anybody? Anybody? 1, 2. No. Lee's like, I don't see anybody with hands up. Who's counting? Okay, who wants to do it with substitution? Okay, 1, 2,
I don't want to do
4,
it.
5.
Ew.
Okay, so we're going to do it with substitution. I thought you
Somebody
liked
raise their
the,
hand.
I thought you liked the first one better. All right, here we go. So we're going to do it with substitution. So circle and sub. What am I circling? Negative 11, x plus 10. That's going to go into the other equation where the letter, what is?
Y.
Now, if these y or if these x's die, it's no or many. And if x's don't die, we're going to have a solution. So let's do the rewrite. Rewrite, here we go. 660 equals negative 17x plus 66 negative 11x plus 10. So 660 equals negative 17x. What is this right here?
726.
726x, and then this one I hear is 660. Okay, put your x's together real quick. What do we get? Negative 743 x plus 660. Now x hasn't died, has it?
Not yet.
Okay, it hasn't. Minus your 660 over. I know you might be running out of room. But something's getting ready to happen that confuses people because the left side's getting ready to die. That's 0. 0 equals negative 743x. Still though, x is not dead. X has a coefficient on it. What do we do to get the coefficient off? Divide. I'm out of room completely, but
We're gonna have a math lab explosion.
math lab explosion.
Jones, don't do it.
I'm not dividing by 0. 0's on top over there. This crosses out. 0 divided by that is still 0. So x is not dead. X is live and it is 0, and you have an answer. So that means how many solutions will the system have? 1. So if you work it out, and really as you do them, as you see x is not going to die, you know you're going to have 1. You can almost stop right here and go, hey, I'm going to CLT that. X isn't going away. And then you know you're going to have 1. If that's all that you have to do on the problem is tell me how many solutions, make sure x doesn't die. If it does, make sure if it's no or many. All right, here we go. Cube's got the problem. And that is it. Yeah, 3, 2, 1. Oh, off the rim, man.